Welcome to the Contribution Session G, Farm Level Analysis. I'm your host today, Silvia from the ONS. All presenters will have 20 minutes for presentation and 10 minutes Q&A. If you have questions, please use the Q&A facility at the bottom of your screen to submit your questions. If you are invited to ask a question, you will be enabled to unmute your microphone. Please then introduce yourself and your affiliation. Please also note that this session will be recorded. Our first presenter will be Oren Zeev from Michigan State University. So over to you, Oren.
Hi, thank you, Sylvia. And I just want to say thanks for having us here, including us in the program. It's a great program. We're really excited to present this work. This is the title of the paper is Productivity Plants, Place and Plants, and it's joint measurement with joint work with Benjamin Schofer. I should say that this paper uses confidential census, U.S. Census economic data, and so the typical disclaimer applies. This is not, our opinions are not the Census Bureau's. Hopefully, they don't disagree too much with what we're about to say, but also like everything has been reviewed to make sure that there's no confidential data being released here. Here we go. To start off, I'll start off with the observation that many people have started off with many times, which is that there are huge differences in economic activity across space. And behind those differences, there are measurable differences in productivity, right? So, we have a lot of theories to explain those differences. There are, all sorts of economic forces you can have been brought to Marshall to explain this. There are, agglomeration forces, selection, sorting, others. And in fact, this paper is sort of just bringing another force as an explanatory force here, which is luck, right? So we want to ask two questions, which are pretty related here. One is, how much do plants differ in their productivity across space, but also in particular, how much do they differ in productivity for reasons that are systematically related to their current location, right? So I'm sitting here in Lansing, Michigan, and you might measure the productivity of workers or plants in Lansing as very high. You might think that that's about Lansing. Something about Lansing is either making plants here very productive or attracting very productive plants or something like that. It might also be the case that what you're really measuring is the fact that there are two very large auto manufacturing facilities here, right? It might just be sort of happenstance that they located here and that you're measuring a high productivity because of that, right? And a closely related question is, if you measure this high productivity here and you're thinking about the marginal plant that's going to enter in Lansing, is that measurement informative about how productive the next plant is going to be, right? So the goal in the paper is to measure the variation in productivity and for manufacturing plants across space, and we're going to use U.S. manufacturing plants census data, but we want to isolate what we call the cross-regional variance in true place effects. So I just want to highlight one thing here, which is when I hear, as an urban economist, true place effects, my mind immediately goes to the causal impact of location on productivity, and that's not what we're worried about here. What we're going to bundle into this term called true place effect is an expected value that might encompass agglomeration forces, the causal impact of location on place, or it might also include things like sorting and selection, right? Things that we might typically other papers want to discern between. We're actually going to all bundle together into one thing. What we're concerned about instead is stripping out variance from those true place effects or from measure variance, stripping out variance that's caused by idiosyncratic plant level heterogeneity, just like the happenstance of the large auto manufacturer locating in Lansing, right? And we're going to call that granularity bias because it's sort of due to the fact that there's just the data itself is granular. There aren't that many plants, right? And there's huge dispersion in productivity in those plants, right? So the key finding in the paper is that the raw variance is really wide, right? There's a large variance across space, which tracks with what you would expect if you just look at any economic data. The 90th percentile plants are basically an order of magnitude more productive than plants in the 10th percentile MSA in the US, right? So there's a huge difference in productivity across space. But 2/3 or 3/4, depending on what measure you're looking at exactly, 2/3 of that variance is unrelated to place. It's actually just granularity in the data, right? Which means that, all the typical economic forces we're, think about as determining the variance in productivity across space really just account for 1/3 or 1/4 of the variance you see, right? So I won't have time to get into it, but so like there's, sorry, let me just say there's, what are the implications of this, right? So we have a lot of models that give us counterfactual results if you're, that think about the reallocation of resources in an economy spatially, thinking about moving people or moving, capital across space, right? When you do that kind of operation, because of these results, you have to start thinking about what margins, on what margins are you reallocating inputs, right? So if you're thinking about an intensive margin reallocation, existing plants just shrinking or growing, then the raw variance that we see is informative for your counterfactual. But if you have a model where there's an extensive margin of plants, like there's entry of new plants or exit of plants, right, then what you're going to be drawing from is a much wider distribution within each location and a much narrower distribution across locations than what you would take if you were just thinking about the raw variance, right? So, a related question we won't really have time to think about too much is this question of, well, on the margin, how important is the next plant that's going to locate in Lansing, Michigan? Will that be as productive as the existing plants, right? And that's a question that's actually more policy relevant potentially, right? Because in other words, if you're a policymaker, you're thinking about how productive will this industry or that industry be in a given location, you might want to think about the measured productivity in that location of existing plants. But what we're saying is basically that that measured productivity will be very uninformative. You don't want to take a very high draw, right, and interpret that as meaningful about the next set of plants in a location, right? In particular, kind of the one extension we do is take the method I'm about to introduce, which is a split sample method, and use that as an instrumental variable, and find that in fact, even in the true place effects, only 60% of the true place effect passes through to the next generation of plants. Okay, so what I'll do for the next 10 minutes, 13 minutes is just give you a sense of the statistical model that we have in mind, right? We don't really have an economic model intentionally. We have a statistical model for what we're measuring, and then just give you the results, briefly go through the raw variance that we measure, and then we'll do two things. One is a permutation test, which essentially is a test of a very radical hypothesis, which is, in fact, the entire variance you see in the data is due to granularity, that there are no true place effects that differ from one place to the other. We're going to reject that, but that will also, the results of that will be informative and say that granularity does seem to be really, really present, or present in a large way. And then we'll constructively give you a correction for the raw variance using the split sample method. The paper does a little bit more work. I'll just mention right now, not just with the extensions to new plants, but also we think about, where does granularity come from in the data? There's really three ways, right? There's the fact that we have finite counts of plants. They're not infinite number of plants. At the location level, there's maybe 100 on average, or 100, or more at the tail. But one source of the granularity comes from the fact that there are too few plants, right? Another source comes from the fact that there's a huge dispersion within location and measured productivity, and then lastly there's the fact that there are also really big plants in specific locations, and those big plants are gonna be weighted more. So we do a lot of work trying to do practical things to get rid of the granularity. The way you might if you're just kind of naively running through the data by cutting out the most granular cells or reweighting, and then there's sort of the sort of sad result there is you don't really get rid of the granularity in the data, but we have this constructive measure to tell you how to deal with it. Okay, so let me just give you a taste of what the paper is actually doing. So we have plants in each location L, right? And each plant is going to have a measured productivity, which is going to be log TFP, which we call A. Right now, A comes from some data generating process, where we're not sure what's going on there, but all the economic forces that we tend to think about in urban economics are in that and affecting that data generating process, right? So there's A is drawn from some distribution of plants F, right? And that's a location-specific distribution. So there could be agglomeration forces adjusting any moment of that distribution. There could be selection chopping off the tail of that distribution, right? But what we're interested in here is the expected value of that distribution, right? So we're gonna define tau, which is the true place effect in blue here, as the expected value of A in a location, right? When we measure a plant's productivity, what we're actually measuring is a combination of tau and an idiosyncratic, deviation from tau, which is about the plant's, the plant's diversion from the expected value, right? So if you're asking, well, how do I measure the expected value in the data of a given location? The obvious answer is to take a mean, right? Now, the mean is an unbiased and consistent estimator of the true location effects, right? So this is typically what people do, operationalized as a fixed effect in a regression. The trouble is when you're thinking about differences across these means, you're actually going to include noise in your measurement. So if you measure the variance, for example, here, you're measuring the variance of these averages, you can split that out to the variance of these true place effects and the average error around the expected value, okay? Now, if just parsing that out here, if we measure the variance as a variance of averages, then what we're measuring is the variance of the true place effect, and in red here, this noise term, which we're going to call bias from granularity. And you can see here, if you if you squint here into the math, it's hard to look at math on a screen, but what is this? This is the average error, which comes from two places. One in the bottom here, the denominator is n. So the fact that we don't have infinite plants in each location means that each location is going to contribute some granularity to the data. And on the numerator here, there's sigma, which is the variance within locations, which we don't have a measure of necessarily, right? But we know that the plants vary in locations around the expected value. Okay, so I'm just going to briefly go through these three first parts of the paper here, just to talk about how we're actually measuring these things in the data. One kind of hitch I didn't talk about yet is the fact that there are lots of industries, right? So one thing you might do is just think about what I just presented within industries, which is one part of what we do, right? So we think about these measured location effects within industries. Typically in urban economics, you think of a location effect as a citywide effect across a lot of industries. So to do that, what we'll do is demean each of these industries and then average across all the industries and to an overall location effect down here, which is the squiggly Greek letter, right? So what I'm going to do from now on is actually going to be a split screen where on the left, I'm going to show you the traditional urban economics, the variance or adjustments to the variance in the traditional urban economics idea of a location effect, which is across all industries. And on the right, what I'll show you is essentially the average within industry effect or within industry variance. Okay, so this is the measured, the naive raw variance across all MSAs, and we have to chop off the tails to make sure that there's no confidential data released here. So that what you're looking at is the 5th to the 95th percentiles. But even you can kind of look at that difference as quite informative about there's a lot of variance in the data, at least in the raw data, right? So plants in the 10th percentile MSA are way less productive than plants in the 90th percentile MSA. And within industries, this is even wider, right? There's a huge amount of variance. There's order of magnitude different between the 90th and 10th percentile, okay? But what we're concerned about is that what's really going on here is you're measuring just the fact that there's a really big productive plant in one location and it has nothing to do with that location. It just, the plant had to go somewhere, right? So the first thing we're going to do is this kind of radical hypothesis. Well, actually, there are no location effects. Everything is due to granularity in the data. So if I, that same variance equation I had up top here, now what we're doing here is essentially a hypothesis that all the location effects are the same, which means that the variance in blue here is 0. And then the existing variance we see is essentially just this variance from the red, right? This is essentially an F-test, but non-parametric, right? So if you put a lot more structure on this, you could just do an F-test of the fixed effects and say, okay, well, pass or fail the F test. Right here, we don't want to say, specifically don't want to say anything about the distributions of productivities within each location, or the true
So you
distributions.
have 5 minutes left out of the 20 minutes
Sure, thanks.
presentation.
I'll try to go faster. But so what we're doing to operationalize this is basically just randomly drawing plants, putting plants into cities and seeing, well, what's the variance that comes out of that, right? So this is the result. This is the 1,000 variances plotted, right? So this is like sort of a dartboard approach, and like Ellison and Glaser, where we're just saying, okay, we're stuffing plants into different cities and seeing what happened, what variance does it emerges from that, right? And the question is whether the dashed line here, which is the true variance, is statistically different from the null hypothesis there. And it's true, actually, they are very different, and it's true even within industries. They're statistically different. One crucial point here, though, is actually the mean variance from the randomized cities is actually very close to the existing variance. And this is where the median permuted economy, the distribution there is very close to the actual distribution, right? So we can't quite say, quantify the granularity in the data from this, but we can say actually, just moving plants around, taking their idiosyncratic productivities, gets you an economy that looks a lot like the existing economy. So let me just kind of quickly talk about what we actually do to quantify the granularity in the data. The idea here is we're going to remeasure productivity within each location, taking means again, but with only half of the sample. So we're going to divide up each city industry into an X sample and a Y sample and estimate the means in those two samples. And the idea here is that the true place effect tau is going to be common to both of those samples. So when we estimate the covariance between them, we're actually going to get an unbiased estimate of the true variance, right? All the granularity will be kind of pushed out of there. So let me just kind of visually explain what we're doing here. On the x-axis here, we have the mean from the X samples of each city. On the y-axis, the same city's Y sample. Now, if all we observed in the data were the true location effects, right, we'd be measuring the same thing twice. And all you'd expect is, all these dots would line up on the 45-degree line. Instead, right, another possibility, right, so that's one benchmark, the 45-degree line. All the true location effect is the entire measurement. The other possibility is the permutation test, which we just rejected, which is actually the entire measurement is just random noise, right? Then you'd expect, two random variables uncorrelated with each other, right? So another benchmark would be there's zero correlation between these two subsamples, right? What we see in the data is something in between, but close to the random benchmark, right? So the X and Y subsamples of the city are not super related to each other, right? And this is true within industries as well. This, in some sense, the coefficient here is almost the estimate we want. The percent of this is the covariance over variance, which is, as we said, the true variance over the variance of the X sample. There's just one technical hitch I don't have time to get into, which is precisely because of granularity, when you take this subsample, you're actually magnifying the granular bias. So the result is this, which is that the covariance between these two subsamples is at the city level about 1/3 of the raw variance. At the city industry level, it's actually 20% of the raw variance. This is much smaller. Okay, so I think let me just say I have 2 minutes here to sort of like wrap up. So let me just kind of say, well, like I said, one thing you might expect is this is driven by the fact that there are a few cities with very few plants in them. So like the easiest thing to do would be to say, hey, let's actually just get rid of those in our data, right? So this is basically the entire paper redone, where we're systematically changing the minimum number of plants required to be in our sample. And what you can see here, so in red, there's the permutation test. In blue, there's the covariance that we get 1,000 draws of these random samples, and the black line here is the raw variance. You see the raw variance is falling. So if you take only cells with only industry city pairs with a huge number of plants, you actually get a lower variance. The problem is that the true variance in those in those pairs is actually falling at the same time. So if in the extreme, when finally to try to get rid of the granularity, you can say, well, I want at least 100 plants in my sample. At that point, you have no variance left. You're only taking the largest cities essentially, and there's actually very little variance in productivity across those cities. Okay, I think I don't want to get into what we do with the old young yet, because it's going to be more than a couple of minutes. So I think I should stop there and conclude. I mean, the punchline here is, yeah, the observed variance is really large, and that matters. It's not that that variance is like a figment of our imagination, but it's not due to the economic forces, and that means it's not super informative about the next set of plants you would expect to locate there. Or if you drew one more plant, what would it look like? It's probably much more close to the average mean than it is to your city's mean. Okay, thank you.
Thank you, Rand. So we're accepting questions. So if you have any questions, please use the Q&A facility at the bottom of your screen. I haven't seen any open questions come up. I'm not sure if it's just me or.
I think I'm happy. So you can interrupt me if there are more questions. I can just talk about what we do with the young plants, because I think that might be interesting. I don't know.
Sure.
So, the next part of the data is thinking about, next part of the paper thinks about, well, like, if we zoom in on the marginal plants, these new plants that are in each location, these are plants that are, 5 years old or less. What do we see? The first thing is actually the raw variance is higher in these plants, which is, so the raw variance across locations is bigger. If you were to super naively take this as a result, you'd say, well, plants are, location matters even more for new plants, right? But if we do the same split sample adjustment for the variance, what we find is actually that the new and old plants, the plants that were incumbents in the area, and which, by the way, dominate the sample overall, and the new plants, they actually have very similar variances. Then the next thing you can do is say, okay, well, let's take the split sample of old plants, let's correlate what's the relationship between the old plants and the young plants, right? So again, we have the potential benchmark that there's no correlation between the old and the young, or there's the full pass through of the location effect, right? The issue here is that the granularity itself creates noise in the data. So you're going to get too close to the zero line here by virtue of the fact that even the old and the old themselves are not super related to each other, right? So the empirical relationship between these two is even lower than in the split sample. Right, so there's almost no relationship basically in the data between old and young plants at a given location and their productivities. But what we can say is, listen, how much relationship should we actually expect to begin with, right? So the true benchmark we should be thinking about is, well, the old and the other old, the two split samples of the incumbent plants, they're not super related to begin with. Another benchmark is, well, the young plants should be as related as them to each other, right? As related to the incumbents as the incumbents are to each other, right? So that would adjust your benchmark downward. The result we get is that 60% of the true place effect for the incumbent plants, we can find in the new plants.
There is a question for you, Oren. We are taking the question from Richard Kiana.
I see that. This is cool. I haven't done this before. So, the developed economic. Should I read it out, or should you read it out? How does this work?
I think Richard should be enabled to ask the question himself.
Okay. Yes. Great.
Oh, I can actually read it out. Okay. The development economics or economic history literature has found that place-specific effect, landlocked, lack of infrastructure, etc., matters a great deal. Do you think the share of these place effects would matter more in those settings or time periods and matters less in places such as the US?
Yeah, so that's a great question. I have like a couple of answers. I don't know, I think they'll probably contradict each other. But one answer is very dry, which is that we actually in the paper kind of ask, okay, is this actually specific to the US manufacturing sector or something like that? That's fair. So we try to replicate this in Europe as well, within European countries. The data there is worse for us. I mean, we don't have census data, plant census data there. So we're using firm level data. The locations are probably not as good, but we actually replicate our results in Europe. That's the driest answer I can give you, which is yes, it's true in other places, at least currently. But the I think the deeper question is, well, like, does place not matter at all? And that's not really what we're saying here. There's kind of there's two ways to think about this. One is, these explanations, these economic explanations we've had, they're actually explaining a smaller subset of the variation than we thought, right? So they're limited in scope, but actually they're stronger. That mean, like the other side of that coin is they're actually stronger explanations for the set of variance that is possibly explainable. And the other part of this question is, like, actually, the econ history literature also focuses a lot on the fact that these sorts of effects they're talking about, they have these persistent effects, right? And this persistence kind of implies hysteresis, or like in fact that's very consistent with luck of the draw, right? It may be the case that that there's like just one really big plant in Lansing that has been there for a really long time, right? That actually, I think, is consistent with the idea that being sort of on a Portage location, which mattered a long time ago, still has a big effect on the economic activity in your location now. Yeah, that's, I think, as best as I don't know if I think I might have dodged the question, but I answered in a few contradictory ways.
Do we have any more questions? I mean, there are still 4 minutes left. If Oren, you wanted to use some of this time to give a bit more information, please.
Okay, I mean, I think sorry, I think I overcompensated for the 20 minutes. I was super concerned about stopping people from answering questions. So I guess let me kind of I can actually show you this. These are the European economies, right? So this in blue, it's the covariance. In black is the raw variance, and in red is the permuted, the set of permuted variances, right? And you have a similar. I should have put this up for the answer, right? So the United States is the first marker here, just like the repeat of what you've seen. And then again, like the caveat here is the data is a little bit worse for us in these other economies. We don't have the full census, and we like the locations of these firms are probably a little bit worse, especially for multi-unit firms, which probably span multiple regions, right? So we're using NUTS 2 regions here, which are kind of consistent across here. But you can see here for the UK, for example, right? So the raw variance in the UK is huge, right? It's as large as the US's, the variance in the US, right? Which is remarkable. The permuted variance in the UK actually looks just like the raw variance, right? So we can't actually reject the hypothesis that, in the UK, these cities are not, really different from each other. It's just the fact that what companies, happen to settle where. And that corresponds to the fact that the covariance here in blue is actually really close to 0. And that's the sort of the true variance doesn't look very overwhelming, right? So, yeah, so the survivals. So sorry, Richard's also asking, just to follow up, do you think that these place effects could affect the likelihood that these productive firms survive in these locations, right? So like a survival bias, and that sort of to me, so I typically call that selection, right? So only certain kinds of firms would persist in a specific location. Like if you can make it in New York, you can make it anywhere. That's the kind of idea, right, behind that. Some locations with really high rents, like London, are going to just only the most productive firms are going to survive there. So it's a super interesting question whether that changes the data. But for us, that's something we want to box, right? So what we do here, I'm just going to kind of scroll. Sorry to close your eyes, not get seasick for a second. What we're doing here is putting that survivorship question into this distribution F. So the way that like selection or survivor, differential survival rates would impact the true location effect is by changing the expected value. So if you have a distribution of potential firm productivities, and you're saying, well, actually, there's some previous distribution, which is like all the people who want to enter the market or try to enter the market, and then like the left tail of that just kind of gets chopped off because they just can't, they're not productive enough to operate, and they close, right? That for us is going to adjust adjust the expected value too, right? That the expected value should move up in proportion, right? And that will be in the true place effect, right? So there's also like the hitch that if you have like an extreme amount of that, you could also adjust the variability, the U, right? So that could actually enter into both the granularity, to reduce the granularity in a specific location, and adjust the mean, right? So what we're not going to be able to say anything about is whether, what the true place effects are, about selection or about anything else. But what we are able to say is, hey, the total effect, the total impact of that differential survivorship on the expected value is actually much smaller than it looks in the raw data. Okay.
Sorry, I'm afraid
Thanks.
this is the end of the 30 minutes. Thank you, Oren. If you can stop sharing your screen.
Yes.
So we have our next presenter, Jonathan Thomas from Accenture.
Yeah, I'm just going to try to start sharing my screen. Okay, it ought to be kind of popping up now. Let me know when you can see it, and then we'll be good to go.
I can see it.
You see the screen?
Yeah.
Okay, great. Okay, so this kind of presentation is based on joint work with my colleague, Tomas Castagnino, who's also on the call. And Tomas is the Global Head of Economic Modeling and Data Science team at Accenture Research. And it's also important to note, just as the previous kind of speaker, we have a disclaimer in the view that, in the sense that this work doesn't necessarily represent the views of Accenture or their opinions. So what's the story here, and what's the context and research contribution? So the background to our work is that the relationship between the current wave of technological advance, in particular automating technologies, and firm and worker outcomes is both theoretically and empirically ambiguous. Now that's fine, because to some extent...
Sorry, Oren, I'm afraid I need to interrupt you. Your voice is really low.
Oh, I'm sorry.
You probably need to get closer to the microphone.
Okay. Okay, I'll speak up. I'll try to speak up a bit kind of louder. Okay. So just to go back, that's fine. It's quite kind of possible for us to have kind of positive and negative, or even kind of zero relationships between various forms of technology and worker and firm outcomes in terms of pay and kind of productivity. However, as ever in economics, the true answer probably revolves around the phrase, it depends. And one of the problems that we see in the literature as it stands is that trying to work out what the it depends actually is very kind of difficult. That's partly because most empirical work looking at these sort of questions involve very heterogeneous technologies that are lumped into one overarching technology kind of dummy, or kind of a percentage of firms that are using kind of robots in a particular kind of location. So they're both kind of cross-industry aggregation and kind of cross-country aggregation. When really, when we think about it, the unit of observation that really kind of matters is going to be at the company level and or at the worker level. And what we have in our work here is at both. So what's our contribution? First, we focus on a specific type of technology, kind of robotic process automation, and we look at it within a firm, in fact, within a business unit, within a firm. That's absolutely kind of critical in order to tease out the key kind of relationships. Now, we'll define RPA in a moment, but in our setting, what it really does is it affects the activities that employees do when they undertake solving a client request within an IT kind of setting. I'll spell that out more in a moment. We also look at how a kind of productivity and at the firm level, at the team level, in fact, and the pay and promotion outcomes of workers varies after this new technology is implemented within the work stream. And because of the units of observations that we have, and some of the nuances that are absolutely critical to how RPA is actually implemented and what it actually does within the workflow, we're able to tease out some new insights. Just before we go on, here's a formal kind of definition of what RPA is. I don't think it's that helpful. Let me give you some example. If you're an insurance kind of company and you're dealing kind of with claims, RPA will help you to assess the validity of a particular kind of claim. It kind of does the bookkeeping work, if you like. And also, if you're a bank and you're thinking about applications for a mortgage, RPA, it can easily kind of sort the wheat from the chaff, if you like. So what does our research kind of tell us? It tells us three things. The first is that we find that RPA does indeed increase productivity when you measure it in terms of the average time it takes to solve a request that comes into the IT kind of workflow. And also, and perhaps more obviously, it reduces the amount of errors that are actually kind of made. But the key point here is that to tease out these kind of productivity impacts is not a trivial exercise. And that's why we believe that aggregated data just isn't going to get you there. Now, for an it depends insight, specifically, we find evidence that RPA actually serves to complement kind of worker managerial skills for those individuals who are at senior levels within the company. That partly reflects that it frees up some of their time in order to focus on more value creating activities rather than to spend their time solving kind of difficult kind of problems. So that's a useful kind of byproduct. And the final kind of result that we find is that even though we don't find a direct relationship between the implementation of RPA and worker outcomes a year after it's introduced, what we do find is that what RPA actually does, it selects in individuals into continuing on the project at hand. And that selection in of high performing individuals who were previously deemed as high performance on various performance kind of metrics, that then tends to enable these individuals to actually get higher performance kind of bonuses in the year after RPA introduction, as well as an increase in the kind of base pay. So with that, let's think about the research kind of design. What we have here is we basically observe a business unit over 2 years from roughly March 2016 to March 2018. In the middle of that, in March 2017, RPA was introduced into the workflow of about 500 kind of workers. And these workers were at different stages of their kind of careers. They varied from entry-level analysts up to senior managers. Now, what they do is they solve a client kind of request or a ticket. Now, a client request can range from a simple, I forgot my password, to something that's absolutely kind of mission kind of critical, i.e. my stack system is just a collapse and no one in the company or in the business unit is able to kind of log in. What we have is about 30,000 of these interactions per month across all of our 500 employees who are allocated to 11 kind of different kind of teams. And what we have is we observe individuals a year before the introduction, and we track them all the way through to a year afterwards, and we can measure their productivity kind of metrics. I'll come into what that actually means in a moment. What we also have is we've merged this data with actual, worker and team characteristics through the human resource function within this kind of business unit. So we have information like their age, their tenure in the company, their education kind of levels, etc. So we're merging both firm level and worker level kind of data into an all singing, all dancing kind of data set, which enables us to track these outcomes over time. This is a critical slide, and this is what really kind of matters, I think, when we're trying to unpick the impact of the technology on the kind of worker and business outcomes. In this particular kind of setting, there are two ways in which RPA affects the company and affects the workflow. The first is monitoring RPA, what we call kind of monitoring RPA, which is shown in the dark kind of purple kind of boxes here. What the monitoring does is it actually anticipates problems before they occur. So for example, it may be able to say, okay, 3 people have had problems kind of logging into the system kind of today. That suggests there might be a systematic kind of problem. Let's look at the problem and fix it before it turns into a ticket or a full system kind of shutdown tomorrow. So that is a kind of monitoring RPA. The second is, if if a ticket actually emerges, so a problem gets through the monitoring stage, is not kind of picked up, it becomes processing RPA. And the key point about at that stage is that, let me take a step back. What monitoring RPA does is it tends to, just by a kind of design, it tends to filter out particularly problematic issues at the outset. So what you see is that by the time an issue gets to being a ticket, it's what we call a low priority kind of ticket as opposed to a high priority ticket. And the critical distinction is that low priority tickets through the service level agreement with the business unit are assigned a shorter period, a longer period, a longer kind of target solution time. Whereas a high priority ticket, because it could bring the whole system kind of crashing down, it's urgent, it's high priority. The service level agreement gives that a shorter kind of target solution time. So as we go through the flow, what we see is high priority tickets tend to get taken out of the system. Low priority tickets tend to stay in the system. High priority tickets have a shorter target solution time and on average do get solved at a shorter time. Low priority tickets are the opposite. So the composition of the pool of tickets that you observe RPA is very different to the pool of tickets in the pre-RPA kind of period. So that means that when you actually come to assess a kind of productivity kind of changes, you have to take that compositional difference into account, and that's what we do. The second point, and I think it's clearer on this slide, is that the monitoring component of RPA actually cleans out a lot of potential kind of tickets that would have made it before RPA came into being, was implemented compared to afterwards. So there's two effects. The number of tickets actually falls, which is the dark line on this slide, and the composition of the ticket pool afterwards actually shifts towards low quality, low priority kind of tickets. How do we measure RPA exposure? Okay, at the monitoring stage, it's measured by the change in the share of high priority that's handled by a particular team. As I said, we have 500 individuals who are spread across 11 kind of different teams. Each team in principle focuses or tends to emphasize some particular aspect of the solution or kind of process. That's also quite important. So the monitoring kind of stage is the change in the share of high priority tickets handled by the team. And as you can see in purple, if you can see in the purple box, there tends to be a decline in that share over time after RPA is introduced. The processing stage, in fact, is a number of tickets, ticket resolution kind of tasks. So if we parcel up someone's job into tasks, the number of ticket resolution tasks that are automated on each team, i.e. that RPA takes over, divided by the number of workers on that team. So those are our measures of RPA exposure. As far as RPA outcomes go in terms of productivity, there are two measures. There's the solution time in seconds. So these are the averages, and you can see there's good variation across the teams. And there's the percentage of solution errors, i.e. the percentage of reopened kind of tickets that takes place across the whole kind of time period. Again, there's fair kind of variation. In terms of the career path of individuals, we look at three things. The first is the likelihood that an individual will continue on the project. The second is the likelihood of them getting a bonus in the year after RPA is introduced. And the third is whether they get an increase or a change in their kind of base pay or not. So let's have a look at kind of productivity. This is another kind of key slide. What we've done here is we've split the tick up. An important, I'm just going to take a step back just to be absolutely clear. What you have to do then, if you're not going to make a mistake when you actually try to assess kind of productivity, you have to compare like with like. So what we do is we split the tickets according to their type. And that means that if the ticket incident is of the same type, i.e. I can't kind of log on, so the same priority, high, low, or medium, it comes from the client's same kind of functional area, and it's reported through the same kind of channel, i.e. someone makes a phone call or they send an email, and it's assigned to the same kind of team. So we are in effect comparing the before and after like with like. having said that then, when we come to this slide, and with that in mind, we look at the quintiles of average solution times before and afterwards, and it's clear. Let me make the point that if you don't do the splits that we've done, what you find is that average solution times actually rise after the rollout, but that is merely a composition effect of the higher share of low quality tickets. So to get the true productivity impact, you have to do that unpacking, okay? So that's solution times, a clear decline. And also, we find that in terms of the share of reopened kind of tickets, the purple line here is the share a bit before RPA is introduced in the 6 months before it is, and the blue line is afterwards. And again, the result is clear. There's a decrease in the percent of errors that are made.
Sorry, Jonathan, sorry to disturb you. You have 5 minutes left within the 20 minutes presentation time.
Absolutely fine, that's plenty of time. So what do we do then? So we throw a regression at the data that we have. And the regressions are fairly kind of standard, but there are some interesting kind of nuances. The first one, in order to pick up the productivity effects, we look at both solution time and errors kind of separately. But this is the key regression, if you like. That's our processing RPA. That's the RPA, that's the monitoring RPA. We allow for the change in the number of tickets. We know that there's a decline in the number of tickets that get through to the processing stage as a result. We've got the share of kind of managers on the team, and we've got an initial condition, if you like, the solution time before RPA kind of kicks in. We have a variation in solution time over tickets, over team, and over kind of time periods. What do the results say? There's a clear kind of negative relationship between processing RPA and solution time, both in levels and in changes over time. So that's reasonably kind of compelling. Also, there's some evidence that monitoring RPA also helps to bear down on solution times. Now, in terms of the type of worker, we also have some interesting kind of results. Given the time left, I'm just going to focus on one. In teams with a higher share of senior kind of managers, that's the channel by which the negative impact on solution time is particularly compelling. So their time, which is particularly costly to the firm as well, which is being spent solving difficult kind of problems, what processing RPA does is it frees up their time by reducing solution times in a particularly aggressive way. This chart just basically, this table rather, just basically makes the point that, as we might expect, kind of processing RPA bears down on errors that are being kind of made at the ticket kind of level. So the share of tickets where you think a solution has been done, you've ticked the box and the company comes back or the client comes back and says, no, it's not been done. Those errors are kind of reduced. Let's quickly have a look at what happens for kind of career paths. It's a similar kind of model, except here, the variation is at the individual kind of level. We've got our processing RPA and our monitoring RPA, again, very similar kind of regression, except the key point is, were you a high performer in the past? Did you get, when we did your performance kind of management, when the client did your kind of performance management, were you viewed as a high performer? What we find is that for those individuals who continue on the project, and this is just some kind of logistic kind of regression, the first point is that there is not a direct impact from either of our RPA kind of measures. But what you do find is that those individuals who continue on the project are more likely to be high performers. Conditional on being a high performer, they're more likely to, and continuing on the project, they're more likely to be awarded a performance award, and any pay increase that they get in their base pay is higher than those who don't continue on the project. So what have we learned? The first is that the details actually kind of matter. It's very important if we're trying to parse out what these key relationships are. I'd argue that aggregate data, we're going to struggle to really understand what's kind of going on. We need specific kind of technologies, and we need to actually understand what the workflow intervention is. Once we do that, what we've found in this particular empirical kind of case study is we find that RPA boosts kind of productivity, especially for those individuals that are kind of senior managers that are probably more valuable to the company and whose time is more kind of precious. The third bullet just says that we don't find any evidence of a direct impact of RPA on workers continuing on the project, their pay or kind of promotions. But what we do find, and the final bullet just says that it seems to be linked to the selection in of high performers. There's something about how RPA is actually implemented in this particular example that it favors those individuals who were already deemed as high performers. And with that, that's it from me. Happy to take some questions.
Thank you, Tom. Thank you, Jonathan. If anyone would like to ask some question, please use the Q&A facility at the bottom of your screen. Any questions? So if there is no question, then sorry, there is, I've got a message here, people having problem using the Q&A facility. So I have a question for you. Oren would like to know if there is evidence of worker adjustment to the technology.
I'll have a go answering that question, and then I'll ask maybe kind of Tomas will kind of chip in. That's a very good question. I'm not clear that we can actually answer that, because what we can't actually observe is the extent to which individuals were forewarned and the opportunity for them to adjust their behavior before the introduction of RPA. It may be the case, okay, that different types of workers, if they feel that RPA is coming, and there probably was some advance kind of warning, would actually, one, adjust their kind of productivity kind of beforehand, and maybe that might occur across kind of different teams. So what we may be kind of picking up is partly that, but I'm actually reassured that if those effects are there, they look pretty small. Okay? There's not a lot of, if you just look at this kind of slide here, you know, there's not a lot of action going on before RPA across the quintiles of ticket solution times compared to after RPA. I want to say that the variation afterwards is much different to the variation kind of before. So if workers were adjusting, their handling of tickets and were kind of boosting their productivity ahead of time in the way that we normally think of sort of like an Ashenfelter dip, where you tend to find that the wages of workers who are about to be kind of displaced start to fall in anticipation of that fall. I don't think we see that here.
Yeah. So I can chip in and add one thing. So that's a very interesting question. We don't have an answer for now. Perhaps as part of a follow-up paper to this one. But it's actually truly interesting to see, you know, the path that that employees that are transitioned out from this specific project looks. And what we already see in the data is that actually those workers that are transitioned out to this project, to another project, actually are taking more training. That's something that we can look at. We don't have, you know, established or solid results, but that's something that you can actually look at the data. Yeah, and you know, it's a fair question, a very good one. Mm-hmm. And very policy relevant actually, because it really takes you to the place where you can talk what is that you can do to help smooth transitions from, you know, one role to another.
Yeah, and also I think it's worth just kind of pointing out a point that I didn't make. When you look at the path of workers from the implementation of RPA to a year afterwards, we find that about 80% of workers stay on the project. 14% of workers move to a different kind of project, but stay within the company, and only 6% of workers end up leaving the company. And that 6% is not significantly kind of different to the normal attrition rates that we would find across that particular kind of business unit. So that in its sense makes me comfortable with the view, without evidence to reject it, of course, that there's not a lot of kind of differential worker kind of behavior taking place as a result of RPA, both in terms of anticipating it and notwithstanding what kind of Tomas has said after it kind of rolls out. I think your mic's off, Silvia.
Sorry, and thank you from Oren for answering his question. So do we have any more questions? If not, then maybe we move to the next. Maybe if not, then maybe we can just move to the next presentation.
Absolutely.
Yeah, thank you. If you can stop sharing your screen. Thank you.
Yeah. Okay.
Right. So now that's my turn. Let me just share my screen with you. If you can see my screen.
Yeah, it's good.
Okay, good. Thank you. Okay. Thank you everyone for coming to my presentation. Today I'm presenting you our paper on business dynamism in the UK, new finding using a novel dataset. My name is Silvia. I'm a senior economic data scientist at the data science campus at the ONS. And this paper is a joint work with Russell, Yousafar, and Mohammed. They're all from the economic statistics group at the ONS, so it's a cross-division collaboration. So our paper focuses on using a novel dataset constructed by using the UK Business Register, and it's our first attempt to use these datasets to examine the UK business dynamism. So I'll start by giving you some background, especially our motivation to look at business dynamism in the UK. And then I'll move on to talk about the data innovation, in particular to introduce you the longitudinal business database, which give us the data sets for our analysis, alongside a couple of other innovations we've made on the data. And after that, I will talk you through some main findings before I discuss some concluding remarks with you. So let's take a look at some background. So business dynamism is a study of birth, growth, and decline of businesses and its impact on employment. A steady rate of business birth and death contributes to economic growth in the long run, and there are growing interest from academics on this topic. So what motivates us to look at business dynamism? We find that UK employment rate reached 76.6% in February 2020, is a record high, up 6% points from 2010. So the most intensive employment growth during the last 2 decades is in the period between 2012 to 2016. In the Interdepartmental Business Register, the IDBR, so IDBR in short, workforce expanded by 3.2 million jobs in growth. The growth in these 4 years was greater than the one in the preceding 15 years. So if job creation and destruction had remained the same as they were before 2008, then only 1.8 million jobs would have been added between 2012 and 2016. So this is primarily because of the reduction in the destruction rate. That is 1.4 million extra jobs were present in the economy in 2016 because jobs were not destroyed as rapidly as they once were. So this highlights the importance of understanding business dynamism to identify the origin of employment growth. So this slides here summarize what we try to do in this in our paper. So we measure employment dynamics of UK businesses from 1999 to 2019. As I mentioned before, we made a few data innovation. So we built on microdata from the IDBR to examine dynamics at a quarterly frequency. So we construct our data set aiming to improve existing use of IDBR snapshot data, which allow us to capture within quarter changes of individual businesses in, for example, their business structure and industry. We also use IDBR pay-as-you-earn pay information to derive employment measure. And we derive a consistent firm age from new activity, entry, and exit measures. So the first data innovation we made is the construction of a novel data set, business database called the Longitudinal Business Database, which aims to improve existing UK databases. And this is an ongoing project at the ONS. So we said the LBD improve existing business database in certain aspects. First of all, it provides a near population coverage with quarterly frequency. Now, existing UK business databases are mainly, for example, the business structure datasets, database, or the ARDX are of annual frequency. Secondly, the LBD would enable multi-level linking of data from survey and administrative source. It's because looking at the existing UK business databases, they mainly focus on a few business units of the IDBR, our UK Business Register. So mainly enabling bringing survey data together. But for the LBD, we make use of all of the IDBR business units, so including the administrative unit, which then allow us to bring the survey and the mean data together. So I would want to point out also that although in our paper, in this particular paper, we haven't actually linked the LBD to external data sets, but we made use of IDBR information from both survey and administrative source. But the LBD does provide a consistent framework to link data from different sources and therefore enable more in-depth research analysis, making it a big improvement to existing UK business databases. So we construct the LBD data sets using consecutive IDBR snapshots. Now, existing UK databases use snapshot data with information reflecting what is true only at the time when the snapshot is taken, and implicitly assume such information is true over a period of time. We argue that this assumption is not realistic, so we construct the LBD using consecutive snapshots and establish rules to capture signs of activity of businesses over a quarter. But because we use consecutive snapshots to create our database, so we can capture continuity within a quarter and also within quarter changes of industry and business structure. Now, so far, empirical evidence uses existing UK databases. For example, the business structure database to draw inferences are restricted by the annual frequency of these databases. A downside is that they observe less changes over time. But since the LBD captures more, since the LBD use quarterly snapshots, we can capture more transition in business structure of firms, allow us to look at firms' transition in more details. Because each cross-section of the LBD by constructions capture all firms as long as they show some sign of activity during a quarter. So it enables us to have more efficient use of data, which means less waste data due to non-match when producing linked data set. I'll further explain these points with an example to illustrate the advantage of the LBD. And later in this presentation, I will show some of our new findings, which is different from existing work. So as I mentioned before, there are issues of using individual snapshot data to construct databases. So because individual snapshot does not capture activity of individual firms over a period of time, because snapshot data only show what is true at the point in time, but not over a period. In our case, not over a quarter. So I would like to further explain that further illustrate this by using an example. So what you can see at the bottom of this slide are 4 different types of firms. Yeah, and suppose that I have 2 IDBL snapshots taken. Yeah, taken from the register at 2 points in time. One taken at time t-1, and the other one taken at time t. And assuming that these 2 times are sitting at the 2 ends of a quarter. Further assume there are 4 firms. One is a continuing firm. 4 different types of firms showing different activity status. So I've got a continuing firm here, which started trading before time t-1 and continue trading until sometime after t. I've got a new firm that started trading sometime between t-1 and t. I've got a deactivating firm that started trading sometime before t-1, but ceased trading sometime between t-1 and t. And then I have an activating firm that started stopped trading sometime before t-1, but resumed trading sometime between t-1 and t. So in the top part of this picture here, I still have these 2. I'm still considering the 2 IDBL snapshot taken at the 2 points in time, and let's assume that I'm using this individual snapshot to construct databases. So what I've got on the left hand side here are the activity status of these 4 firms in the cross section of the database at t-1. Which are constructed using individual snapshot, the snapshot t-1. And on the right here, I've got the activity status of the 4 firms, which are in the time t cross section of the database, which is constructed using IDBL snapshot taken at time t. So let's suppose that I have a survey that is sampled between these 2 points in time, between t-1 and t, also sometime, somewhere in between. And then I wanted to link this survey to the firms in the databases. So, however, I do not actually have a snapshot that is taken between time t-1 and t to construct another cross section. To construct another cross section of the business database. So what do I do then? Whether I link the survey to the cross section at t-1 or the cross section at time t, I will end up having a match. For example, if I'm linking the survey to these set of firms in the time t cross section of the database, I will have a non-match from the activating firm. But if I'm linking it to the database at t-1, I'll have a non-match from the new firms and a non-match from an activating firm. So either way, I'll end up having a non-match and causing data being underutilized. So for the LBD, we design criteria to identify firms that have shown some sign of activity over a quarter t. So please note the notation. I'm using capital T to denote a quarter, but small t to denote a point in time. So the LBD will capture all the 4 types of firms, but with markers showing the activity status. So as long as a firm or has shown some sign of activity, it is captured by the LBD. So we, in order to identify the active firms or active enterprises in this case, we modified the criteria used by the ONS business demography to consecutive IDBL snapshots to identify active enterprises. This involved comparing turnover, employment, number of live VAT unit, value added tax, and pay as you earn pay unit. So and then by doing this, it will give us the quarterly active enterprise populations. So using based on the data sets we draw from the LBD, we made another data innovation, which is to establish an age estimate. Now, as discussed in existing literature, it is hard to distinguish genuine births of enterprises from pure legal and administrative changes. So firms' birth and death variables presented in the present in the IDBL snapshots are inaccurate. So our age measure counts consecutive quarters with signs of activity. So it accounts for periods of disrupted activity. So our measure will then provide us with some understanding of how firm age and dynamism of UK businesses relates. So we have two different age measures at 2 points in time if a firm becomes inactive and then reactivates. And we count 4 quarters of inactivity to restart the counter. So because we think that disruption in activity that lasts for 1 year is reasonable enough to consider it as a new entity. And also note that our age estimate is different from a conventional age measure. It is a straight measure of time in which the business is substantively active to an extent to qualify for inclusion as an active enterprise. So moreover, we also has established an employment measure using administrative information from the PAYE units. Note that the IDBL enterprise employment records are mainly derived from the Business Register Employment Survey, we call it BRES in short, complemented with other surveys and administrative sources. But existing UK business databases takes information about firm level or employment level information from the IDBL. So the main source of this information are from the survey. But we use the IDBL PAYE information. So we use administrative information to derive employment measure. We count a number of employees on the pay scheme in real time as enterprise employment. And for enterprise with multiple pay units, we then aggregate the number of employees of all its pay unit to the enterprise level estimate. And for those enterprise that are not covered by PAYE, we use BRES and other smaller surveys. Just to give you an idea, the number of enterprises for which we have valid pay data is 57% in 1999, rising to 78% in 2019. But over 92% of total employment in our active enterprise populations is derived from the pay, the administrative source. So, and this coverage is relatively stable over time. So having looked at certain data innovation and having introduced you the longitudinal business database, let's take a look at some major findings we obtained. So this table here shows the employment contribution for 2 periods, 1999 to 27 and 2011 to 2019, due to job creation and destruction. And what you've got in the last column is shows the change between the 2 periods. So the main message from this table is that in the decade to 2019, business dynamism, defined as the rate of entry and exit of businesses, has declined in the UK, in particular through reduced job destruction due to closing businesses. We also found that incumbent created fewer jobs and destroying more jobs. We compare our finding with some existing work. For example, Pressure et al. 2019. They used the business structure database to calculate annual job destruction and creation rates from 1998 to 2018. They found that the net effect of incumbents is greater than new businesses, so which means existing firms created more jobs. But what we found is that new firms created more jobs than existing firms. So this graph here shows the job creation and destruction by firm size. It shows the difference between the two periods, 1999 to 2007 and 2011 to 2019. In quarterly average contribution by new and closing businesses. So the two main messages from this chart. First of all, micro firms are responsible for the decline in job destruction rate from exit. And the decline in job destruction for micro firms is larger than the increase in job creation after the 2008 and 2009 economic downturn. And the second message is that large firms have experienced a substantial decline in both job creation and destruction. So we've compared our findings with existing work. For example, Anya Disdains et al. 2013, they investigate job creation and destruction in the UK using the business structure database, and they found that small firms are responsible for a significant amount of job creation. But we found that micro firms are job destroyer, despite the reduction in the gap between job creation and destruction rate after the 2008-2009 economic downturn. So we think that we can further conduct further investigation to better understand these results. For example, for micro firm, we can further link productivity data to our data sets, which will help us to understand what kind of micro firms, whether they are productive or unproductive, have contributed to the decline in job destruction. Our finding for large firms reflect a decline in corporate and public sector restructuring in the UK. And we suspect that this is to some extent linked to mergers or administrative changes rather than genuine economic changes. So as the registration of entity within a large firm groups are restructured, but this can't be confirmed without further information, for example, data on mergers and acquisition linked to our data sets. So this graph here shows the change in job creation by new firms and destruction by closing firms by industry between 1999 to 2007 and 2011 to 2019. We look at entry and exit only, so I ignore the incumbent. The main messages from this graph is that job destruction by closing businesses has fallen across all industry since the 2008-2009 economic downturn. In all industries, this was accompanied by a fall in job creation rates from new firms. So in other words, the decline in business dynamism was widespread across the economy, not concentrated in any industry. So we do find less jobs were destroyed after the crisis, but we can't really say whether it's due to labor hoarding. That's why it is important to link productivity data to further investigate the cause of it. Right, this table here shows the job creation rates by new firms and job destruction rates by closing firms, by age bands. So the main message from this table here is that age has an important role in UK's business dynamism, both in terms of job creation by entry and job destruction by exit. So young firms are creating and destroying most jobs over the last 20 years. So we've also done some international comparison. Sorry, one thing I forgot to mention is that our approach to construct age measure allow us to accommodate a temporary pause of business activity in an old enterprise that might have become inactive for a quarter and then reactivate in the following quarter, possibly due to unusual events or because of a seasonality of business operations in some sectors. So we think that further data is required to understand whether the enterprise has gone through an event like merger, acquisition, or takeover, or to investigate into whether the enterprise has been relinked to another enterprise group or have its own lower level IDBR business unit moved to another enterprise. So as I mentioned, we've also done some international comparison. So this chart here shows you the gross job flow by intensive and excessive margin between 2010 and 2001 and 2010. So we compare the UK on the right with the OECD on the left. So for by intensive margin, we mean that job flows by new and closing firms. And for intensive margin, we mean job flows by incumbents. So note that we use the average gross job flow from our dataset for the UK, but the OECD compute their average flows for 18 countries, including Great Britain. So the main message from this table here is that the trends are similar, but UK figures are larger in magnitude, especially for incumbents. So UK also presents a more persistent decline. So we've also done some other international comparison. For example, UK's contribution to, we look at the SME, and then we find that UK's contribution to job creation and destruction from young SMEs to total employment is similar to its counterparts in countries like US, Canada, Italy, and France. We also compare the annual extensive and intensive reallocation rates for the US and the UK, and find the extensive margin trends and levels in the UK are consistent with those of the US. So an intensive margin shows more differences between the two countries. So now the concluding remarks. So our paper focuses on the constructions of a novel dataset, namely the longitudinal business database, using the IDBR. We use these new datasets to investigate business dynamism in the UK. So there are lots of potential to further extend our work, especially on to improve or improving on the improvement of the dataset to create the possibility for further analysis. So our data sets capture activity and changes for enterprise over a period of time. So we can further improve our data set, which is something that we are actually currently doing, within the ONS, is to link all the IDBR business units together to establish a longitudinal identity spine. This will provide us with a consistent framework to link survey and admin data over time, which then allow us to construct different linked data sets for multiple purposes, whether it's for research, analysis, or production of statistics. I also mentioned earlier that some of our findings can be further looked into by linking our LBD data sets to, for example, productivity data or M&A or mergers and acquisition data, if available, to gain better understanding. So the LBD will enable us to further explore the use
Silvia,
of administrative data. Yes.
Just over 5 minutes left until 4:30.
Okay. Okay, and to conduct a subnational level analysis. It will enable us to establish consistent measure of firm entry, exit, and growth. So as I mentioned, this is our first attempt to use the LBD to conduct analysis. And if you are interested in knowing more of what this data set could tell you, there's another paper my colleague at the ONS is presenting on firm life cycle and choice of legal form on Thursday at 1 o'clock. Thank you.
Can I ask a quick question?
Sure.
Yeah. The first is, when you looked at the cross-country analysis, have you looked at a relationship between business dynamism and...
Sorry, I cannot hear you, sorry.
Oh, I'm sorry. Have you looked at the relationship kind of at the cross-country or the cross-industry level at business dynamism and the kind of productivity, you know, the level space or kind of changes space? So that was one question. And the second one was that you didn't say anything about why you thought that your results may have differed from the previous kind of literature. You put 2 examples where there was a contrast, but I wonder if you had any ideas on why your results were different. Thanks very much.
Yes. Okay, at this point, I can also invite Josefa, my other co-author, to join in the discussion. So I can address your second question. When, say, for example, we go back to look at the OECD results, and then we think that yes, we do take a look at we realize that the result is a bit different, but then we also note that this is mainly because first of all, the OECD is using we are looking at the UK data only, and the OECD is using data average over 18 OECD countries, including Great Britain. And secondly, the OECD is a measure is at an annual level, but we are using quarterly measures aggregated to the annual level. So because we are looking at quarterly frequency, so we do actually observe more fluctuation over quarters, as compared to if we're only just looking at the entire year. Sorry, what was your first question? If you can remind me. Sorry, Oren, I thought you have the first question.
No, I'm sorry. I'm good. I don't have any questions. I'm actually.
Sorry, not Oren. Sorry, it was Jonathan, right? Sorry.
I'm sorry. I muted myself. Yeah, I just wanted to say that the relationship between kind of business dynamism and the kind of productivity, whether you looked at that either at the cross-industry or the cross-country kind of level.
Sorry, I really can't hear you. Can you?
You've said that kind of business dynamism has fallen in the UK. So I wondered if there's a relationship between that decline and sluggish kind of productivity in the UK.
You mean when we compare with the international, why that was the reason?
Whether there's a relationship between the two.
I'm not so sure whether we have actually looked at it. Josefa, correct me if I'm wrong. I don't think we have.
Yeah, no, we haven't looked at it yet, but of course it's one of the things we want to look at, especially because this decline in business dynamism is coming from firms that are not closing and small firms that are not closing. So we want to link this like a big amount of small firms that are remaining in the market and see whether they are like low productive or not. But that's something we haven't done yet, but we definitely want to explore.
Yeah, and also actually, as I mentioned before, because this is the first time we look at business dynamism using this new data set. So a lot of these analyses are still quite descriptive. And then we realized that there are a lot of things that we as well as finding some sort of major findings, we also open up a lot of questions. For example, so when we find that, with the findings for the small firms, say, as I mentioned before, without actually linking it to other data sources to further understand, our findings, it's very difficult to identify the cause. For example, we're also aware that, if we could link the data to, for example, like the merger acquisition data, would be much better in identifying, what is actually causing, what is the reason underlying some of our findings. For example, the findings for the large firms.
We're at 11:30, but should we just take a minute if there are any other questions? There are no open questions. Does anyone want to add anything? Sorry, I was using Eastern time, but we're at 16:30.
Yeah, all right, thank you. I guess that's the end of this session. Then thank you very much for everyone for everyone to join in.
Thanks very much. Bye-bye.
Bye-bye.